In this video for section 2.7, first we're going to talk about the horizontal line test for inverse functions. We talked earlier in the course about the vertical line test, and as you remember, the vertical line test tells us whether or not a graph is a function. If we use the same type of test but instead use horizontal lines, then that will tell us whether or not a function has an inverse that is a function. So if no horizontal line intersects the graph at more than one point, then the inverse is a function. If there is a horizontal line that crosses the graph in more than one point, then the inverse is not a function. So we're going to look at example 5 first. It says, which of the following graphs represents functions that have inverse functions? So we think about drawing horizontal lines across the graph. And for the first graph, I see that each line only crosses the graph in one point. And so that means it has an inverse function. Now for part B, you can see that if I draw a horizontal line like right here, then I have the horizontal line crossing the graph in two different points. And that means that it is not an inverse function. Same thing for part C. I can draw a horizontal line that is going to cross the graph in multiple points, in this case 3 points. And since there's a line like that, that means it does not have an inverse function. Looking at part D, all of my horizontal lines cross the graph in only one point. And that means it has an inverse function. So next you should look at checkpoint problem number 5. Do these in your notes, check your answer, and then move on with the video. So next we're going to talk about finding the inverse of a function using a graph. So if we have a point on the graph of a function, a comma b, if we switch the x and y coordinates, that gives us a point on the inverse function. B comma a is a point on the inverse function. And then the other aspect of this is that the graph of the inverse is a reflection of the original graph over the line y equals x. So this purple line here is the line y equals x, and you can see that the graphs are going to be mirror images of each other if you look across that line. Or in other words, if I were to fold the graph along the dotted line, then these two pieces would line up exactly. So next we're going to look at example 6. It says to use the graph of f in this figure below to show the graph of its inverse function. So for the graph of the inverse function, what I'm going to do is I'm going to switch the x and y coordinates of the labeled points. So the point 4, 2 on the inverse is going to be the point 2, 4. So I'm going to mark that point. That's right here. The point -1, 0 is going to go to 0, -1. I'm just switching the x and y coordinates. So 0, -1 is down here, and then I'm going to connect those 2 points with a line because 4, 2 and -1, 0 are connected with a line. And lastly, I have the point -3, -2. So if I switch the x and y coordinates, my point on my inverse is -2, -3. And that's going to be right here. And then I'm going to connect those 2 points with a line as well. So if you look at my graph, my original graph and my new graph of the inverse, it should look like they are reflections over the line through y equals x. And if I draw that line in here, I can in fact see that that is the case. So next you should look at checkpoint problem number 6. Do this in your notes, check your answer, and then move on to the homework.